So we're going to finish up the notes today. So again, you need to memorize these 6 trig functions. Find a way to remember it. Remember that sine is y over r. Cosecant, its reciprocal, is r over y. Cosine, x over r. Secant, r over x. Tangent, y over x. And cotangent, x over y. So find a way to memorize these. Also remember the cool little acronym, all students take calculus. That'll help you to check to see which ratios or which functions are positive in which quadrant. Be able to do this on the quiz on Wednesday. Be able to take an order pair and then find the 6 trig functions. Remember, you're going to find r by using that r equals x squared plus y squared and square root it. Once you have x, y, and r, plugging them into those 6 functions is super easy. Just remember that if you have a radical order pair, a radical in one of your order pair coordinates, you're going to have to rationalize. This were the quadrant angles and then the reciprocal identities. We've already saw these when we set up those functions, the y over x for sine, and then its reciprocal. Y over r, and then r over y for its reciprocal, which is cosecant. So we've already seen these, but memorize these. Be able to use a reciprocal identity. And we did examples here where these are both reciprocals to each other. So to do cosine, all you got to do is flip the fraction and make it 3 over 5. Notice for this one, once you flip it, you would have to rationalize it. So just be careful on those. Memorize these Pythagorean identities. You will have to use the Pythagorean identities on the quiz, and that's what we're going to do today. Again, the quotient identities, we're really not going to use those yet. They will be coming up. And then the solution intervals, that's what you needed to use to make sure that your answer makes sense. In the homework, you had to say possible or impossible, using the knowledge you have about the solution intervals. They are, but you need to memorize these. So the one that I'm going to use, since I'm trying to find sine and cosine, but they gave me tangent, I'm going to be using this one because that's what was given to me. Once I figure out what secant is, then I can turn it to its reciprocal to make it into cosine, and then I can use the second Pythagorean identity, the first one, to find the next one. And I'll show you what I mean by all this. And this is where we left off. Now, notice the instructions here say to use the Pythagorean identities. Now, technically, you could probably graph this order pair and get the answer that way. However, if the instructions say use Pythagorean identities and you do not use Pythagorean identities, you will get the question wrong. So, for example, this question, if I were to graph this, remember tangent of theta is y over x. So if they've already given me what tangent equals, and remember in quadrant 3, the signs are negative, negative. So if my signs are negative, negative, this told me that this initially was -4, -3 to turn into +4 over 3. So this order pair for tangent is going to be located down here at -4, -3, actually backwards, sorry. It's going to be -3, -4. But I don't want to see you do this. This would be a way that you could check your answer. What I want you to use is Pythagorean identities. So if you want to have these written down somewhere, so you can maybe take a screenshot and put them on your work here so you can know. So here's what we need to do. We're using the identities, and I'm going to use 2 identities for this problem. I'm going to be using tangent squared theta plus 1 equals secant squared theta. Because remember, secant is the reciprocal to cosine. So what I'm going to do is I'm going to take what tangent equals, this 4/3, and I'm going to plug it in here. However, notice this is tangent squared theta, so when I put in the 4/3, I've got to square it. And then I'm going to put plus 1 is equal to secant squared theta. I need to square that and then add it to 1. So 4/3 squared turns into 16/9. I'm going to be adding fractions here. So I'm going to change my whole number 1 into 9/9. And this is equal to secant squared theta still. I'm going to add those fractions. Once I add the fractions, I get 25/9 equals secant squared theta. Notice what I'm asked to find is just sine squared theta, or just sine theta and cosine theta. So I need to square root this in order to get just secant. So I'm going to square root both sides. This gives me plus and minus. The square root of 25 is 5. Square root of 9 is 3. And this is equal to secant theta. Now, what's important here is that they told us which quadrant we want to find these answers for. So this is where my all students take calculus comes into play, because in quadrant 3 here, the only ones that are positive, the capital T, stands for tangent and its reciprocal. All the other answers are negative. So this tells me this secant answer, I'm going to get rid of the positive and only keep the negative. So from here, I'm only keeping negative 5/3, which is equal to secant in quadrant 3. Now, it didn't ask me to find secant. It asked me to find sine and cosine. So to find cosine, since I know that cosine is the reciprocal to secant, all I need to do is flip that fraction upside down, because it's the reciprocal. However, now to find sine, I need to use another identity. And the identity I'm going to use to find sine is the first one from the previous slide. Sine squared theta plus cosine squared theta equals 1. I'm going to take what I just got for cosine and plug it in here and square it. So sine squared theta plus -3/5 squared equals 1. Going to square the fraction. It becomes 9/25. This would be a plus sign. I'm going to change this whole number 1 here. I'm going to make it a fraction. So when I move the 9/25, it's easy to subtract. So I'm going to change it to 25/25, because my goal is to isolate sine squared theta. So now I have to subtract 9/25 from both sides. And now I'm left with sine squared theta is equal to 16/25. I don't want sine squared, I just want sine theta. So square root both sides. And now sine of theta is equal to plus and minus 4/5. But again, in quadrant 3, sine is negative. So I'm going to only keep the negative here. So sine of theta, -4/5. So again, my two answers here, sine theta is equal to 4 over 5 negative, and cosine theta is equal to negative 3 over 5. Yes, I could have graphed the ordered pairs, and I could have used the r equals x squared plus y squared and then square root it. However, if you do that on the quiz on Wednesday, you will get it wrong. Even if you tell me these are the correct answers, without all of this work to back it up, you get it wrong. You must demonstrate the use of the identities. You must memorize the identities. Pretty good there. Let's try the next one. This time they want me to find cosecant. They're giving me cotangent. I have an identity on the previous slide that tells me that 1 plus cotangent squared of theta is equal to cosecant squared theta. So all I'm going to do is take what they gave me, this cotangent, plug it in and square it, and then get my cosecant after I add 1 to it. So I'm going to do 1 plus negative 1/2 squared is equal to cosecant squared theta. Once I square the 1/2, I get 1/4. Now I need to add these fractions. So again, I'm going to change my whole number 1 here, so it has a common denominator. I'm going to change it to 4 over 4. I'm going to add those. 5 over 4 is equal to cosecant squared theta. I don't want cosecant squared. I just want cosecant. So I square root both sides. And this ends up being plus or minus the square root of 5 over 2 is equal to cosecant theta. Again, they told me which quadrant this is in. They said 4. So in quadrant 4, all students take calculus. The only ones that are positive in quadrant 4 here are going to be cosine and secant. All the other ones are negative, so I only keep the negative again. It's not always going to be like that. It all depends on which quadrant they're telling you your answer is located in. So this is negative square root 5 over 2 is the answer to cosecant of theta. Now, when you're doing the homework, some of the questions only ask you to find one thing. Other questions, the ones towards the end, are going to ask you to find all 6. So again, once you find one and you need to find its reciprocal, just flip it. If there's a radical on the bottom, you'll have to rationalize. So the next one, we're going to do, the next one we don't need to use an identity. It doesn't tell you. It just wants us to find the value of all 6 trig functions. So let's try the next one. All right. So for this one, it says find the value of the 6 trig functions of an angle in standard position running through the ordered pair -4, 0. Soon as you see you have a 0 in your ordered pair, this is a clue that this is going to be from one of the quadrant. It's not in the quadrants, it's from the axis. So this is located on one of your axes, and you can see that it's -4, 0. So we can see that it's going to be on the x-axis. So let's go ahead and see what we got here. These are called like the quadrant angles, but let's go ahead and see this order pair. Let me graph it. So remember, when we did these, we only saw the ones that had a radius of 1, or we just used the first order pair for each one. So this is 0, 1. Remember, this was the 0, the 90, the 180, the 270. Over here would be -1, 0. And then over here, 0, -1. Now, I'm going to show you why I'm writing down these first order pairs. Anytime they give you an ordered pair that's on either the x or the y axis, you can just use these ordered pairs instead of the one that was given to you. Because if you use the one that's given to you, it's still going to simplify down to the same answer. So notice this ordered pair that's given to me, -4, 0. It's over here. It's still a 180-degree angle, no matter where the ordered pair is located. So what I'm going to do here is I want you to write down the 6 trig functions for the 180-degree angle, because that's the terminal side where this ordered pair is located. Now, let me show you if I use the original versus using this ordered pair instead of the -4, 0. So, for example, in my ordered pair, I know that x is equal to -4, y is equal to 0. I need to find the r value for the 6 trig functions. So what we would do is r equals x squared plus y squared under the square root, -4 squared plus y squared, r equals 16 plus 0, the square root is 16, plus and minus 4. But again, r is always positive, so we only want to keep the 4. So there's my 3 values that I need. And if I start putting them in, so if I take this, for example, for sine, I'm doing the sine of 180 is what I'm doing here. So remember sine, y sin, so y over r. And if I put this in here, 0 over 4, it just simplifies to 0. If I do cosine of 180, it's x over r, and my x is -4 over 4, which is -1. Notice if I would have done the ordered pair -1, 0, x equals -1, y equals 0. Remember the radius when you use those 4 ordered pairs is always a 1. So if I would have done cosine of 180, instead of using -4, 0, and instead use that one, it makes my problem a little bit simpler, because then I don't need to reduce. You can choose any time the ordered pair that's given to you is on the x or the y axis. You don't have to use that for your x and y. You can use the 1, 0, the 0, 1, the -1, 0, or the 0, -1, depending on which part of the axis that point is on. Now, if that confuses you, use the given and then find your r value and then plug them all in. So I need to find all 6. Let me just go ahead and do tangent, and then I'll do the reciprocal. So again, either way, I'll just go ahead and finish this using the original given. So for tangent, it's y over x. And then if I plug it in, 0 over -4, this one gives me 0. And now I can do all the reciprocals. The reciprocal, remember to sign, is cosecant. Flip it. And then now this becomes 4 over 0, and this is undefined. Over here, reciprocal to cosine is secant. Flip it. And it's 4 over -4, which is -1. And then cotangent, 180. Flip it. And then again, it's going to be undefined. However, you don't need to use the -4. You can replace that -4 with a -1 and still get these same 6 answers. And this is only for those quadrant angles, the 90, the 180, the 270, the 0, or the negative. it will still all give you the same answer. Now, for the last part, what we need to do is figure out the values of these in order to solve these things or to simplify. So let me show you what the next one is. So it wants me to simplify 3 times the secant of 180 and -5 times the tangent of 360. So what I'm going to be doing here is using those quadrant angles, I'm going to figure out what the secant of 180 is and the tangent of 360, and then go back and multiply. Now, I just did all the 180s on the previous slide. Again, I can quickly review that with you. So over here, my 180-degree angle is here, 360 is here, 90 here, 270 here. So for the 180, this is where we use the order pair, the -1, 0. So for secant, remember secant is the reciprocal of cosine, so r over x. Remember, whenever you use the 4 points here, the 0, 1, the 1, 0, or the 0, -1, remember the r value is always 1. So I'm going to put this in here, 1 over, and I'm using -1. So the secant of, let me change this theta, to 180 is going to be -1. So I'm going to come here, 3 times -1. Now I have to do the same thing for tangent. Okay, tangent of 360, it would be this angle here. So this is going to be the order pair I'm using. So for tangent of 360, remember that is going to be y over x. So 360, the order pair is 1, 0. That's your x, your y. So when I plug it in, 0 over 1 equals 0. So now here, I'm going to do 5 times 0. And I'm going to do the math here. 3 times -1, -3, minus 0. And the answer here is -3. Let's try the next one. We just did tangent of 360, so I already know that that's 0. Now let's do sine of 180. Let me come down here again. So the 180-degree angle is here. So the order pair I'm using is -1, 0. So -1, 0, this is for the 180. So this is x, this is y, and remember r is always equal to 1. So sine of 180, y over r, 0 over 1, and that equals 0. So now I have plus 4 times 0. And now notice this one is cosine squared 180. So let's first find cosine 180. So same order pair here, but remember cosine of 180 is going to be x over r. So -1 over 1, and it's -1. So now I'm going to take -1, plug it in here, but I got to square it. So now I have 0 plus 0 plus 2 times 1, and my final answer is 2. Yes. For example, in the homework tonight, it'll say something, let me add a page here. In the homework, they're going to say, identify the quadrant or quadrants for the angle satisfying the given conditions. So for example, they're going to say, given that the sine of theta is greater than 0 and cosine of theta is also greater than 0. This statement means that these are both positive answers. If I would have said the sine of theta is less than 0, then that would have meant that it's negative. But I want to figure out which quadrant the answer where theta is going to be located. So here's how we do this. All students take calculus. So remember, in quadrant 1, all 6 are positive. In quadrant 2, the only ones that are positive are sine and cosecant. In quadrant 3, tangent and cotangent are the only ones that are positive. And then in quadrant 4, it's going to be cosine and its reciprocal secant that are positive. So what I'm going to do here is I'm going to come and I'm going to put check marks in all the quadrants where sine is positive. Sine is positive here and here. Then I'm going to come here and I'm going to put check marks in all the quadrants where cosine is positive. Here and here. And then the quadrant where you have the double check mark, that is the answer. So the angle where sine is positive and cosine are both positive is going to be quadrant 1. And that's your answer to your problem. So you're just going to locate the quadrant where the given information is given to you and then put check marks to figure out where it's going to be located. So that's all you're doing on 59 and 57 in the homework tonight.